This is section 2.4, multiplication of matrices. And this is a little different than addition or subtraction. There's a definite rule. And so our rule here is, in order to multiply, the columns in the first, the number of columns in the first has to equal the number of rows in the second. So it's really nice to write down the sizes of the matrices that you're about to try to multiply, and these numbers in the inside have to be the same number. So in this case, we could multiply A times B, and order matters. And then the outside numbers tell you the size of the matrix that would be your answer. You can use the calculator for multiplication, and I've pulled the parts about multiplying from your matrix note sheet that's provided. When you go in, you're going to have put in two matrices, so you would have done that by editing, and you have A and B, and then you could either just go back in and get the name of A and add B, subtract B, or multiply B. So it's real easy to do once you're in the calculator. Okay, so really that is it for the notes. That gives you a heads up on what we're going to be doing. Let's look at the problems. All right, number one gives you a matrix and says find the value of 3a. When you multiply a matrix by an outside number, that number is called a scalar. So we are multiplying 3 by every item or element in the matrix. So we end up getting negative 21, negative 21, 15, negative 12. So whatever that scalar is, you multiply by every element in the matrix. Number two gives you two matrices and says subtract 4 of these minus 4 of these. So I did that in 2 steps and did it by hand and multiplied this one by 4 and got this, and this one by 4 and got this. Then I subtracted these, so 32 minus 0 is 32. 16 minus a negative 12 is 28. Negative 12 minus a negative 16 gives you positive 4, and negative 4 minus a negative 16 gives you a positive 12. So just be careful on your signs when you're doing the subtraction. All right, it gives you that A is 1 by 5 and B is 3 by 1. So I wrote those down, 1 by 5, 3 by 1. Remember that these two numbers in the middle have to be the same in order for us to multiply. So our choice here would be the product does not exist. Those aren't the same numbers. All right, how about the product of B times A? So I write them down, but I put B first, 3 by 1 and a 1 by 5. Well, in this case, they are the same number, so we could multiply B times A, and we would get the size of the product is 3 by 5. Remember, the outside numbers give you that size. And so then this is just a question, and it could be the same question or a different one on your problems. To find the product matrix AB, the number of rows of A must be the same as the number of columns of B. I think I said that backwards. I read it from left to right, I think. To find the product, the number of columns in the first one, so the columns of A, must be the same as the rows of B. All right. All right, find the following matrix product if possible. So we've got what? A 2 by 2 and a 2 by 1. And so yes, we can do that, and we should get a 2 by 1 as an answer. So let's put this one in the calculator. I'm going to get my calculator open up here, and we'll actually go through this one completely and let you see what happens. Okay, so we're going to go to second matrix, over to edit. All right, and we want to know the size, so we're going to put this 2 by 2 first. All right, and I have a 7, a negative 9, -7 and 1. Let me get this up where I can. Okay. All right, so then I second quit. I want to go back in, second matrix, over to edit, and before I hit enter, I want to go down to B because that's the one I want to edit. And that one is a 2 by 1. All right, and I'm going to put in 8 and -8. And when I'm sure I've got it, second quit. All right, so now I want to perform the multiplication of A times B. So I go back into second matrix, choose A, multiplication sign, go back into matrix, and grab B. So I have A times B, and that is my answer. Let's get that back up here. So 128 -64. So anytime you're doing multiplication, I would suggest you do that by calculator. It's much easier. It's not bad, and we're going to use that a lot. So you would do the same thing for this one. You would put in a 2 by 3 for A, and for B, a 3 by 2. And you know you're going to have a 2 by 2 as an answer, which you end up having there. All right. So this one, number 7, I'm getting some stuff here, says do A times, and this is in parentheses, so take note here. We have a parentheses here. And there it is. Wasn't showing up. So you put in A, put in B, put in C. Then when you come to do the operations, you grab the name of A times parentheses, then get the name of B plus the name of C, close parentheses, and you should get the right answer. But you do need to put that particular sum in parentheses. All right? All right, let's look at number 8. A's shoes and B's footwear both have outlets in City 1 and City 2. And then it gives you A's sells shoes for sandals, boots. B's prices are, and it gives you those. Half of all sales in City 1 store are shoes, 1/4 sandals, 1/4 boots. And in City 2, the fractions are this. So that's your information that you're given. Write a 2 by 3 matrix called P that represents prices for the 2 stores and the 3 types of footwear. All right, so in P we have 90, 60, 120. That's going there. And then in the second row we have the other prices, 60, 30, 150. So that's that matrix. Write a 3 by 2 matrix called F that represents the fractions. So remember up here there wasn't a fraction given, it just said half. So we have 1/2, 1/4, 1/4, and then 1/5, 1/5, and 3/5. So we've done part A and part B. Part C, only one of the 2 products, PF and FP, is meaningful. Determine which one it is. Calculate the product. All right, so if this is P and this is F, we see that we could multiply. Whoops, this is being weird. I'm not sure what's going on there. We could multiply that one easily and get a 2 by 2 product. Now, if we were to do it the other way around, FP, then F would be a 3 by 2 and P would be a 2 by 3. So we could multiply F times P, but let's see what this actually means and which one makes the most sense. So if we multiplied P by F, let's think about, and if we did it, we would get this matrix. Let's see if this makes sense to us. if the cities were across this way, the columns, and the rows were the different manufacturers, the A's and the B's. So would this make sense that A has average price of $90 in city 1, $102 in city 2. B has 75 in city 1 and 108 in city 2. That makes sense. And then if you look at the next part of the question, it asks you to actually talk about and relay what that means. So the entries in the first row, first column, and first row, second column represent the average price for a pair of footwear in an outlet manufactured by A in city 1 and 2 respectively. So that makes sense. And then second row, first column, and second row, second column, that's manufactured by B in city 1 and 2. So that should make sense. D part, from the answer to part C, what's the average price for a pair of footwear at an outlet of B's in city 2? So if we've written it like this, B, city 2, 108 should be our answer. So hopefully that one will make sense for you. And that should take care of our problems for this section.